When you're adding and subtracting in scientific notation, normally when you're adding decimals, you would just line up the decimals and add. But with scientific notation, this here being 10 to the fifth and this being 10 to the sixth means that the decimal's not in the same location for both of these. In order to add these, I'm going to need to change the exponent here so that they're the same, either come down to 5 here or up to 6 here. So in order to change this one to be 10 to the sixth, I would have to move the decimal over one spot. And since I've moved the decimal one to the left, in order for this to still be 4.54, I would have to multiply this by 10 to have the decimal there. So since I'm moving it that way, I increase the exponent over here from a 5 to a 6. Now that they're both 10 to the sixth, then I'm able to add the 0.454 and 3.29 together. So 3.29 and 0.454 gives us 3.744 times 10 to the sixth power. And this one's done. In order to be able to add these, I'm going to have to change the 34,000 into scientific notation, and I need for the exponent on my base 10 here to be a 4. So in order to do that, I would move the decimal to the left 4 spaces, which gives me 3.4 times 10 to the fourth plus 2.3 times 10 to the fourth. Now I can add the 3.4 and the 2.3. And the 5.7 is going to be times 10 to the fourth power. And this one is done. Increasing the difficulty here, we're going to be dealing with negative exponents, and it still works the same way for adding. This one is going to have to be 10 to the minus 2 power also. So what might help is looking at the 0.0865 as being times 10 to the 0 power. That's our start, and 10 to the 0 power is 1. So in scientific notation, without moving the decimal, this is our starting point. Now, in order for this to be 10 to the minus 2 power, I would actually have to move the decimal this way 2 spaces. That gives us 8.65 times 10 to the minus 2, and adding 2.34 times 10 to the minus 2. Now we just simply add by lining up the decimals, and we get 10.99, and this is times 10 to the minus 2 power. Now, this is not in correct form for scientific notation. I need to have only one digit to the left of the decimal, so we would rewrite this as 1.099. And since we've moved the decimal now one space to the left, I need to increase the exponent by 1. So I get 10 to the minus 1 power. And this one is complete. This next practice problem is very similar. I need to change the 0.00465 into scientific notation. So I'll just rewrite 2.58 times 10 to the minus 2 plus, and this has to be the same power of 10. So in order for me to change this to scientific notation, I need to move this way 3 spaces. So when I do that, I would get 4.65 times 10 to the minus 3. So now in order to be able to add these, they have to have the same exponent. So I have to either change this one to minus 3 or this one to minus 2. It doesn't matter which one I do. So I'm going to move this one over. So I have 25.8 times 10. And I want to reduce the power by 1. So this is going to be minus 3 plus 4.65 times 10 to the minus 3. Now I have the same exponents, so I can now add them. So I have 25.8 plus, lining up my decimals, I get 4.65. I'll add a 0 here. I get 30.45 times 10 to the minus 3 power. Well, this is not correct scientific notation. I need to move the decimal one space here. So this would be 3.045 times 10. And since I'm moving the decimal this way, effectively dividing this by 10, I need to also at the same time increase this power by 1. So increasing it by 1 makes it 10 to the minus 2. And that's our final answer. With this practice problem, we're moving into subtraction, and it works the same way. In order to subtract, I need to have the same exponents here. So since they are already the same exponents, I'm able to subtract 9.17 minus 9.06. And once I do the subtraction, I have 0.11, and this is times 10 to the fourth power, but it's not in correct scientific notation form because there has to be one digit to the left of the decimal. So when I rewrite this, I make it 1.1. This is effectively what I'm doing is I'm multiplying this by 10. So I want to reduce this. So over here, I'm multiplying it by 10 to the third power. So instead of times 1,000, it's times 100. And this is the correct answer. Now, in this next problem, we see the first is in scientific notation, but the other is in standard form. So I want to rewrite this so that this is going to be 10 to the fourth power. If I move the decimal 3 spaces, it would be times 10 to the third power, and we need it to be 4, so we're going to move 4 spaces. So on the next line, we have 9.54 times 10 to the fourth minus 0.871. I dropped the 0 here. Times 10 to the fourth. Now I'm able to line up decimals and subtract. And once I'm done subtracting, I have 8.669. That's times 10 to the fourth power. And checking, this is in proper scientific notation, so no adjustment to the power of 10 needs to be done. So this is our final answer. So in this practice problem, some differences. Over here, I see that I have a negative exponent, and I need to change this from standard form into scientific notation with a 10 to the minus 4 power. So I want to move the exponent this way 4 spaces, which gives me 8.95 times 10 to the minus 4th minus 6.04 times 10 to the minus 4th. Since I now have the same exponents, I'm able to subtract, which gets me 2.91, and this is times 10 to the minus 4th power. Again, since I have one digit to the left of the decimal, this is in proper scientific notation, so this is correct. We'll do one more with the exponent being negative. Over here, this is in standard form. To change this to be scientific form with 10 to the minus 3rd power, I would move the exponent this way 3 spaces, which gives me 38 times 10 to the minus 3 minus 8.3 times 10 to the minus 3. We have the same exponent, so now we're able to subtract. Once I subtract, I get 29.7, and this is going to be times 10 to the minus 3. And I see that the problem here is I have 2 digits to the left of the decimal, so I need to take this down to 2.97. And since I'm effectively dividing this side by 10, I need to increase another multiple of 10. So I'm going to increase the power here by 1, and moving 1 higher is minus 2. And that one's done.